Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We from Group 1 MCTA 2102 Section 1. We would like to present about our lab project, Future of Plant Care, which is automated plant watering system. Before we go into details, I would like to introduce first our group members. The first one is Cik Muhammad Daniel bin Cik Suhaimi. Next is Johan Arifin bin Azman. And lastly, me, Muhammad Adli Fahmi bin Tajul Aris. To make it short and simple, our system includes a moisture sensor to measure the moisture in the soil, then send a signal to a relay to start the watering process. Upon receiving the signal, the pump is activated. It draws water from the tank and push it through the pipe toward the soil. As the reason we choose this project is because its efficiency and consistency. An automatic plant watering system can eliminate the need for manual watering, saving time and effort. So this is a component we use to make the automated plant watering system. We have power source, jumper, relay, tube, battery storage, mini water pump, soil sensor, jumper, container, and soil. And next to it is the setup for our project. As you can see, we have power source, connect to the relay, water tank, and sensor.
Hi, Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to present a demonstration for our project. So this is the 5 volt power supply, which is equipped with a turn on and off switch. We use 4 AAA batteries to power up our project. The power supply is connected with jumpers and they are connected to the relay. The relay are connected to two things. The first one being the water pump inside the water, and then there's a hose that is connected directly to the soil, and the second part is the soil sensor that is connected to the relay, which will detect the soil moisture. Next, I'm going to show you what happens when I turn it on. When I turn it on, you can see that the soil sensor is still wet, so I wipe it off to make it detect that it is dry. So when the soil is dry, water supply will come out of the hose. Eventually, when I put the soil sensor back, it will detect that it is moist now, and then the water will stop supplying. Thank you so much.
Hi and Assalamualaikum warahmatullahi wabarakatuh. So my part is water flow model. Okay, what is water flow model? Okay, water flow model is how water can be moved from the container to the tube. And the answer is impeller. Okay, so what is impeller? So impeller is a rotating component used in various machines and devices, primarily in pumps, turbine and compressor. Impeller transfer energy from the motor that drives the pump to the fluid being pumped by accelerating the fluid radially outwards from the center of rotation so it can increase the fluid's pressure and flow rate. Okay, so for the part mathematical model, water flow. The volume of the portion of the fluid in a pipe can be written as V equals to AD, where A is the cross-sectional area of the fluid, D is the width of the portion of fluid. See the diagram below. We can substitute this formula for the volume V into the volume flow rate to get the following. Q equals to V over T is equal to A dt is equal to A d A times D over T. So this diagram for the pipe which we can calculate the volume. Okay, so the mathematical model show the relation between electrical and mechanical systems. So for this project, we use amateur current circuit. Okay, so the DC motor convert electrical energy into the mechanical energy. The electrical energy supplied at the amateur terminals and it's converted into controlled mechanical energy. So for the formula is P equal to theta dot S over VAS equals to K over by RA plus SLA times GS squared plus BS plus KB KTS. Okay, so the pump specification. Okay, we use for this project, we use water pump R385 DC motors and motor pipes. Okay, so this water pump requires between 6 until 12 volt DC, requires between 0.5 until 0.7 ampere. Okay, it flows 1 until 3 liter per minute, and its maximum height 3 meter, while its maximum section range 2 meter, and inlet pipe diameter is 60 millimeter, and the size is 86 times 43 millimeter. Okay, so for the conclusion, based on our project, we combine the three elements needed, which is electrical, mechanical, and hydraulic, which is fluid system. We have used the impeller for our water flow model, and it transfer energy from the motor. Okay, for the DC motor converts electrical energy into the mechanical energy. The electrical energy supplied at the armature terminals converted into the controller mechanical energy. The impeller acts as a mechanical element which will produce torque required to transfer rotational motion for water to flow using a turbine system of water pump. For the fluid system, however, for the fluid system, it can be seen based on how the fluids behave in motion inside the tube. Okay, to sum it, we can conclude our project objective is to combine the element within electrical, mechanical, and fluid system. That's all for me. Thank you.